We are now on the analytical geometry section of this paper. And question 3 says, in the diagram, we have triangle ACD has the vertices where we have A being just A, and then D is 3 and -9, and C is -9 and 0. So that is on the x-axis, where A is a point in the second quadrant. Okay. And they tell us that B, which is -1, and K, that lies on the side DC, as we can see there. Okay, so the first question is calculate the gradient of DC. Okay, so how do you find the gradient of DC? Well, as you can see, we have 2 points, so we can find the gradient using the gradient formula. So the gradient is equal to y2 minus y1 over x2 minus x1. Okay, so with this, just make sure to be consistent. If you start with this as your x2, then that needs to be your x1. You cannot say this one minus that one and then this one minus that one, okay? Then that's where the mistake happens. Okay, so we're just going to say it's y2 minus y1, so we can just say 0 minus -9, which is 0 minus 9, right? And that just becomes a plus 9 over, and we have -9 minus 3. So -9 minus 3. And let's just see what that gives us. So the gradient there is, we have 9 over, and that gives you -12. Then we just have to simplify that. So looking at them, they both have a highest common factor of 3. So if you divide by 3 on the top and bottom, 9 divided by 3 is 3, and -12 divided by 3 is -4. So that is our answer. The gradient of line DC is -3 over 4. Moving on to the next question. Then our next question is to determine the equation of DC in the form y equals mx plus c. Okay, so find the equation of DC. We already have the gradient of DC, so to find the equation, we can use the y equals mx plus c formula, or you can use this one, y minus y1 is equal to m times x minus x1, which I honestly prefer using. Okay, so all we really need here is we just need the gradient and 1 point on the graph. That's going to go in place of x1 and y1. So we're going to go ahead and just pick the easiest point really. So the easiest point here would be the C. So -9 and 0 can be our point. So keep that -9 and 0. That's our x1 and that's our y1. So that is y minus, and the y1 is 0, is equal to, our gradient is -3 over 4 multiplied by x minus, and that is minus -9, which becomes a positive 9. So we just have to simplify. Y minus 0 is just going to stay y because it's y minus nothing. And then we're going to distribute here, which is -3 over 4x. And distribute, you can see that if you say -3 over 4, they don't have anything in common like diagonally, so it's just going to multiply. -3 times 9 is -27, so over 4. And that's just our answer. That is the equation of line DC. Okay, moving on to the next question. The next question, 3.3, says, show that k is equal to -6. Okay, so where's k? K is over here. And do you see that it lies on line DC? So because it lies on line DC, you can use this equation to actually find that corresponding y value, because that's what k is. It's a y value that belongs to this x value of -1. So substitute -1 in place of x and you'll get your y value. Or you can just substitute the -1 and k in place of x and y. Okay, so we can just say the point B is -1 and k. So we're going to take that as our x and that as our y value. So this is our equation. In place of y, we're going to say k is equal to -3 over 4. And then in place of x, we say -1 minus 27 over 4. Okay, so this is, we just have to solve and simplify. So that's going to give you +3 over 4 minus 27 over 4. 3 minus 27 is -24. So that's -24 divided by 4. 24 divided by 4 is 6. So that is, therefore, k is equal to -6. Okay, because it's negative. So there we go. That is our answer. And moving on to the next question. Now 3.4 says calculate the length of DC. Okay, yeah, they put in a lot of focus on that line DC, but our points are 3 and -9, and C is -9 and 1. So just put that down. 3, -9. C is -9 and 0. Okay, it's on the x-axis. Okay, and we're just going to find the length. So you need the distance formula, which looks like this. And we're finding the distance of line DC. Okay, so x2, that's going to be our x2. So we say 3 minus x1, which is -9. So it's -9. And if you distribute, it will become a +9. So all squared plus y2, which is we have -9 minus 0 all squared. Okay, so you're just going to have to simplify this and find that answer. So this is equal to 12. That's going to be 12. 3 plus 9 is 12. So 12 squared is 144. -9 minus 0 is -9. Squared is 81. And so if you add these two together, we just need a 60 from here. If you add that 60, that's going to be 204, but you'll be left with 21. And that's 225. Okay, so you're going to have 225, the square root of 225, which is 15. Okay, so distance of DC is equal to 15 units, and that is the distance. Okay, moving on to the next question. 3.5 says calculate the ratio of dB over DC. Okay, so dB over DC. Let's just see where that is. Okay, so dB over DC. We already have DC. We found that to be 15 units. So all we need to do is find dB. Okay, and we already know what K is. K was -6. So we have D, which we remember, and as you can see here, that's 3 and -9. And B is -1 and -6. Okay, so we just need to find that length. Then we can put them over each other. So again, the distance formula, but we can just substitute at this point. So x2 minus x1, we can just say 3 minus -1, which is +1, all squared, plus y2 minus y1, which is -9, and that becomes -6, which is +6, all squared. And we can also just find this. So square root of, that gives you 4 squared, which is 16. This is going to be -3 squared, which is 3 squared is 9. So that's +9. 16 plus 9 gives you 25. So that is the square root of 25, which is equal to 5 units. Okay, so we know what dB is now. And so that would mean that dB over DC is going to be equal to, we're taking dB as 5 units. DC, we remember, is 15 units. So over 15, and that would just simplify to, they both have a common factor of 5. So divided by 5, 5 divided by 5 is 1. 15 divided by 5 is 3. So the ratio is 1/3. Okay, moving on to the next question. Okay, we are on 3.6, and it says, if M is a point on AD such that AC is perpendicular to MB, calculate the ratio of triangle MBD over triangle ACD. So you can kind of already see what they're doing here. They're taking this triangle and they're saying if there's a point M on AD, okay, such that we have AC, right, that line being parallel to that new line that gets drawn. Okay, so that's M over there. Okay, so yeah, we can actually just do that. So we put down M here, and then if you connect them, they are saying such that these two lines are parallel. Okay, so we have parallel lines there. Let me just put it like that, at least M. Okay, parallel lines. And now we need to find triangle MBD. Let's just be sure about that. MBD over triangle ACD. Okay, so MBD. What does that look like? That's over here. MBD, the smaller triangle, over ACD, which is the bigger triangle. So that one over there. That's really all they're saying. Okay, so just remember that these are specifically speaking about the areas of the triangle. So there are two ways to find the areas of triangles. You can use a half times the base times the height. But as you can see, we don't have a height. We don't have any perpendicular height in any of these triangles. So we can use the second method of finding the area of a triangle. If you have a triangle, and let's say this triangle is called ABC. To find the area of this triangle, you can use the area rule, and that looks like this. A is equal to a half multiplied by the one side. So let's say you were given the angle A. Okay, so it's a half multiplied by the side next to angle A multiplied by the other side next to angle A, which is AC, and then sine of angle A. So that's how it's going to work. Now, with these ones, you will notice that these two triangles are actually sharing a common angle. And that angle that they're sharing is D. And that's going to be our advantage. That's what we're going to take advantage of. The fact that they're both sharing that. So you see by where we have sine angle D, when finding the areas of these two triangles, right? They're going to eventually divide by each other and cancel. And we'll just be left with whatever units was there. And those would divide and we would get the ratio at the end of the day. Okay, so let's go ahead and do that. Let's see what we have with these two triangles. In the blue triangle, we have, well, we just found this. We found that BD is 5 units, okay? And we know DC is 15 units. But we also know now that BD over DC is 1 over 3, like we saw here, okay? We simplify that to 1 over 3. So what we can do with that is, because we have parallel lines, we can use the proportionality theorem to get ratios for this side, okay? Now, let me not just jump to conclusions. The whole point for getting these sides ratios is because you see how they're both sharing this angle, angle D. Okay, because they are both sharing that angle, we're going to take that side over that entire side. Okay, and see how they're both sharing this angle, angle D. Okay, so when you're looking at finding the area of that, you're going to have to use this side, and that center angle. Likewise, with a bigger triangle, you're going to have to use this side, and again, that center angle, angle D. Okay, so that's why we would find these ratios. Okay, so first of all, we already know that DB over DC is 1 over 3. So we're going to actually write the ratios down, but let's actually just put it down so that we can write the proportionality theorem. Well, this is not really Euclid, so you don't have to give reasons. So when we're looking at those two triangles, we can also just tell them that DM over DA, that is going to be equal to 1 over 3. Okay, so DM over DA is equal to 1 over 3. And the reason why is because you can see that BD over DC is equal to 1 over 3, simplifies to 1 over 3. Okay, and so these two, that's really the proportionality theorem, because we have a line drawn parallel to one side of the triangle. So it makes those two sides to be in proportion. So if we know that DM over DA, right, is 1 over 3, that is DM over DA. How you can write that down as ratios, because we don't actually know what the value, okay, of these ones are. We don't know the length of the line, but that is fine because we can still work with this. So what we can actually do is we're going to name them according to what their ratios are. You see that DM has the ratio of 1. So you can give it a variable value, okay? So you're saying whatever this line is, right, that DM is going to take one part of it. So I can call that A. And that DA is going to take 3 parts of it. So we can call that 3A. Okay, so there we've already named them. And now we can actually use this in that area formula. So remember that we're just trying to find the area, okay, the ratio of the area. So the area of triangle MBD over the area of triangle ACD. Okay, so that is equal to, and we're going to say, so the area of triangle MBD, that's the smaller triangle. So the formula for that area is a half multiplied by, and you're going to say the side length, okay? So since we have already seen that this angle D is the center angle and it's been shared by both triangles, we're going to focus on that as the available angle that we have. So we're going to use the side lengths or ratios that we see. So you see that MD is A, so a half times A multiplied by the side length of 5, okay, and then sine of the center angle, which is angle D, over, same thing here with the bigger triangle. So it's again a half multiplied by the side ratio that we have, okay, because we don't have the length, but we have a ratio. So 3a multiplied by the side 15 units, and then sine of, again, angle D, because it's also sharing that angle, and that's the angle that we have, or the angle that we've chosen to use. Okay, so that's what we have, and now we don't really need that anymore. And if you simplify this, this is what you're going to get now with this. So do you see that a half and a half, they would divide, okay, and become 1, and then a and a would also divide and cancel, and it's still that 1/3 that is there. See, 1 on top and the 3 on the bottom. That's exactly what would have happened regardless of whatever length it was. The ratio was 1/3, meaning it is shared, as in the one line gets one part of whatever the full length of that line is, and then the other line gets 3 parts. That's just really the ratio that it's been shared in. Okay, so that's why it doesn't matter whether they give you the ratio or the actual length of the line. And then here, we'll leave that for now, and you see that sine of angle D and sine of angle D would cancel. So all you are left with there is really just a 5 on the numerator over, and on the denominator you're left with 3 times 15, which is 45. Okay, these are factors. We have a common factor of 5. 5 divided by 5 is 1. 45 divided by 5 is 9. And that's our answer, 1/9. Okay, that is it for 3.6, and we move on to 3.7. Okay, we are now on 3.7, and 3.7 says, if it is further given that the gradient of AD, okay, the gradient of AD is -4, and the length of AD, okay, length of AD is the square root of 612 units. Calculate the coordinates of A. Okay, let's see what this looks like. They're giving us a lot of information about the line AD. Okay, we don't really need these anymore. So AD, they tell us the gradient of AD and the length of AD, which is that 612, right? Those are the two things they tell us. So how can we use this to find the coordinates of A? So the thing is, we should try not to get stuck here, because the thing is, they're given a lot of information. They gave the length of the line and the gradient of AD, -4. Okay, that is a lot of information. And we just have to see how can we use it to find A. Okay, so we're not going to find that by guessing, but what we can do is, when we look at A, right, it's a point in the second quadrant, like they also said. How can we find the point A? What are the things we would have needed to find the point A? Well, for us to find the point A, because it lies on this line, at least if we had an X or Y value, we would have been able to find it, okay? But then giving us an X or Y value is already too simple. It's like this one. So what do we actually need? They gave us the gradient though. If we had the equation of the line, I guess, and we had one point, we could find it. However, we don't have the equation of this line. We do have the gradient though, and the gradient can be used to find the equation of this line. Okay, so we can actually attempt to find the equation of this line using what we have. So we know the gradient. Okay, we actually can. We can find the equation of this line because we know the gradient and we have one point on the line D, okay? Because it's the line AD. So we can find the equation of this line, and then when we find the equation of the line, how can we use it to find what exactly A is? Okay, that's probably where this comes in. They gave us the length of that line. So if we find out what the equation of the line is, let's say it's y is equal to, I don't know, 2x plus 3, for example. It's obviously not, it's a decreasing function, so it can't be. So let's say negative 2x plus 3. And let's say that was the equation of the line, right? What we could actually do here is, even if we don't have this full point, look at how we can actually use this point. Because we don't know what this is right now, we can call the x value, we can call it x, and the y value is y. However, you see that we have y is equal to negative 2x plus 3, right? So we could just substitute that as the y value, 2x plus 3. And there, now you have a point that is in terms of x. If you use that, okay, and you use the distance formula to find AD, because we already have the length of AD, it will become an equation that will be in terms of x. Okay, so that is really just the logic behind it. Let's go ahead and actually apply this now. So we have everything that we need. So the first thing is find the equation of line AD, because you've been given the gradient and you have 1 point on the line, which is 3 and -9. Okay, so let's go ahead and do that. We're just going to say that the gradient of AD is -4, like they told us, and we already know D. Okay, that D is that point 3 and -9. So the equation of this line, y minus y1 is equal to m times x minus x1, and this is y minus, and that's -9, so it becomes a +9, is equal to -4 times x minus, and that's a 3, and then we just simplify. So this is equal to, let's distribute -4x, that becomes a +12, that comes over and becomes a -9, and we're left with the y here. So y is equal to -4x, and 12 minus 9 is +3. +3. Okay, so that's what we have there. Okay, that looks good. And now we can just take this like we have this, right? We know that A is unknown, so we don't have the x or the y value. However, we can give it an x and y value. We can call the x value x, and because the y value is y, what does y stand for? What is y equal to? It's equal to -4x plus 3. So we say -4x plus 3, we'll hold that as our y value. Okay, and remember they gave us the length. The whole point is we're going to use the fact that they gave us the length of AD to find this. Okay, so we have this as our coordinates for A, and D is what? D, we already had that, which is 3 and -9. So because they gave us the distance, right, of AD being square root of 612, we're going to use the distance formula. So the distance, and we put down the formula, and we're going to have that AD, well, I can just call it AD. We know what AD is already. The distance is the square root of 612. So we can say square root 612 is equal to, and here we're just going to substitute everything that we have. So that is going to be the square root of x2 is, well, I'm just going to take that, these ones as x2. So it's x minus 3 all squared plus, and then y2, again, top minus bottom. So -4x plus 3 minus -9, which of course becomes a +9. Okay, all squared. So it's really just simplifying here. That's all we have to do. Okay, we have a square root on both sides. You can actually just get rid of it by squaring both sides. And we're going to now have that 612 is equal to, and that breaks open as well. And you now have this in here. Okay, but we can just work on already distributing. So you have x minus 3 all squared. Square the first term, that gives you x squared. Square the last term, that gives you +9. Then say double of the first term, which is x, multiplied by the second term, which is -3. Okay, x times -3 is -3x, times 2 is -6x. Okay, so we have that done. And then here, that just needs to be simplified. So plus -4x, 3 plus 9 is 12. So plus 12 all squared. And then we'll also just distribute that. Okay, so I mean, we can take that 612 over now already. It's fine. So that's going to be x squared minus 6x plus 9 minus 612. I can just see it as 9 minus, it's just going to become negative. So just say that minus 9. Okay, 12 minus 9 is 3. So that's 603. That's -603 that you're going to get there, -603. And then we can just go ahead and distribute that. So that's going to be the first term squared, which is 16, positive 16x squared. Last term squared, positive 144. And then first times second term, and then times 2. So double first times the second term. That's really what we're saying. Okay, first time second term, that is going to be -48. 48 times 2 gives you 96. So that's going to be -96x x. Okay, you can you can just make sure with a calculator. I don't know, these days I don't really feel like using the calculator too much because I'm trying to rely more on my brain rather than always using the calculator. I feel like it makes you less confident sometimes, but do it when practicing. Okay, in the exams, the calculator is your friend. Make sure to always double check. Okay, and then we can just simplify. 0 is equal to, and so we're adding these two together. So that gives you 17x squared. And let's see, this and this. Okay, that's like saying 96 plus 6. 6 plus 6 is 12. That's 10. So 102. So that gives you negative 102x. And we're done with that. Okay, and then we have the constant. Okay, so because it's negative 603, right? Plus 144, you can use the calculator, but 603, and I'm just going to say minus 144, but we're just going to remember that the answer is going to be negative at the end of the day because you're taking a negative number and you're adding a positive that is not as big as the negative. So it's not enough to make it positive. Okay, so that borrowing. Okay, so 5, can give this one the 9 and that one the 10. So that gives you the 100. Okay, so that is 13 minus 4, which is 9. 9 minus 4, which is 5. And 5 minus 1, which is 4. So 459, right? So that is going to be negative 459. Okay, and it is equal to 0 as we can see. So then we have these three. Yeah, at this point, I'm just going to use a calculator because really no use stressing yourself. Okay, so we have to factorize this and it looks complicated. However, I see an advantage here. The fact that we have 17 in front of x squared. Okay, 17 is a prime number, so we can't really divide by anything other than 1 and 17. So it's probably the case that all of these, right, are multiples of 17. Okay, so we'll have 17 in them at least. So we can actually check that out. 102, I'm already going to say, yeah, let's just divide both sides by 17, but we'll also just verify. 0 is equal to, that would be x squared, and then 102 divided by 17, okay, that's a factor, that works, is negative 6, so it gives you negative 6x, and if we change that to 459, 27, okay, so that works out, so they actually do work. They have 17 as a factor in them, 27. So negative 27. And now we can just factorize this trinomial. Open up two brackets is equal to 0, x multiplied by x. And then factors of 27 that can give us negative 6. Okay, that can be 9 and 3. So negative 9, positive 3. So that still stays negative when you multiply them, but negative 9 plus 3 gives you negative 6. Okay, so that works out fine. Minus 9 plus 3. And then solve for x. It therefore means that x is either equal to positive 9 or x is equal to negative 3. And now we're going to decide. Remember that this is the value of a we're looking for, right? What did they tell us about a, or where is a really? Okay, so you can see where A is. It's in the second quadrant, and they also said so. A is a point in the second quadrant. So we got the x values. Do you see that in the second quadrant, it would have a negative value. So you have to take the negative 1. So the answer here would not be the 9, it would be the negative 3. So that's the A value, and then we need to find the Y value of it. So you have the x value. How do you find the Y value? We already have the equation of that line, okay? Substitute it into this equation, which is negative 4x plus 3. So we're saying y equals negative 4, and in place of x, negative 3 plus 3. Okay, and that gives us, that's going to be positive 12 plus 3, which is 15. So A is negative 3 and 15. And there we go. Okay, so that is it for question 3.7, and that is it for question 3. And we move on to question 4, which is on more analytical geometry. We are on question 4, and question 4 says, in the diagram M, which is 1 and 3, as you can see, is the center of the circle. The circle cuts the x-axis at N. ST is a tangent to the circle at P, as we can see over there. Then we have R, which is D and 1, with D being greater than 0. Okay, so it's just positive. It's on the positive side. And L lies on the circle. So L lies on the circle. O and V are the x-intercepts of PL and RL respectively. Okay, so we have O and V, which are the x-intercepts of their respective lines. The first question is write down the coordinates of L. Okay, let's look. Where is L? So L's over here. And as you can see, they told us that M is the center of the circle. So that makes PL a diameter and M is the center. We can use the midpoint formula to find this. So we're looking at this as if this L, right, the X and Y value will just be X and Y since it's unknown right now. And we're actually just finding or working through this as if we're finding the midpoint of PL. Okay, so the midpoint of PL, we will find that by saying x1 plus x2 over 2 and then y1 plus y2 over 2. But here's the thing, we already have the midpoint of PL. That is M. So we're going to replace that with midpoint of PL. That is M. And we can just tell them that is that 1 and 3 that we have. And it should be equal to the midpoint of PL because it is the midpoint of PL. So this is the way we find the midpoint of PL, and that is the actual midpoint, okay, of PL. So we're looking at it as x1 and x2. We'll take that as x1. So that is x plus the second x value, which is 3, x plus 3 over 2, and then y1 plus y2. So that's y plus 9 over 2, y plus 9 over 2. Okay, so one is the actual midpoint of PL, the other is the way you find the midpoint of PL. So they would be equal to each other because they both represent the midpoint of PL. So because of that, we're going to equate them. This is an x value. Because they're equal, the x values are exactly the same. So you're saying that 1 is equal to x plus 3 over 2. And again, because they're exactly the same, the y values should also be the same. So 3 should be equal to y plus 9 over 2. Okay, so here you can just go ahead and multiply both sides by 2. If you do that, you're going to get 2 is equal to, but on this side, the 2 will cancel. Okay, so we get that, and that's just going to be, now we're left with the x plus 3. Then take your 3 over, and so that's a 2 minus 3 is equal to x. Therefore, it means that x is equal to negative 1. Okay, so we have the x value there. Now the y value, again, we're going to do the same thing. You're really just multiplying both sides by 2, and so that gives you a 6 is equal to, that cancels with that, and now we have 9 y plus 9, right? And then take the 9 over. So that's 6 minus 9 is equal to y. Therefore, y is equal to negative 3. And that means that this point over here, the end point L is negative 1 and negative 3. Makes sense for where it is. Okay, so that is the first question. Moving on to the next question. The next question, 4.2, says, determine the equation of the tangent ST to the circle P. Okay, let's look at that. The tangent ST to the circle P. We need to just find the equation of this line. Okay, they told us that it's a tangent. So what do you know about the tangent? And do you see that from M to P you have a radius? Okay, what do you know about a tangent and a radius? A tangent, okay, is always perpendicular to the radius at the point of contact. So because they're perpendicular lines, okay, there's something we should know about their gradients. If you take the gradient of two perpendicular lines, right, and you multiply them together, they will give you negative 1. So we can actually use that. So that means that if you want to find one of those gradients, let's say it was M2, let's say it was M1 you were looking for, you would divide both sides by M2. Okay, so the gradient of the one line will be equal to negative 1 divided by the gradient of the other line. Okay, and that's really what we're doing here. So the first thing we're going to find, because we need the equation of this line, that's a tangent. Okay, we don't have the gradient of that. However, we can find the gradient of the radius. M to P gives you your radius. So we're going to take those 2 points and find the gradient. So M, that is just 1 and 3 like we saw. And P is 3 and 9. So 3 and 9. Let's find the gradient. So we can say gradient. I don't think we really need the formula. We already wrote it down before. So we're going to just say 9 minus 3 over 3 minus 1, which is 6 over 2, which gives you 3. 6 divided by 2 is 3. So the gradient of that line is 3, right? The gradient of the radius is 3. So to find the gradient of the tangent, we just say m of radius. So it means that the gradient of the tangent can be found by saying, again, remember, it's -1 divided by the gradient of the radius. Okay, so it's -1 over 3. You can also do that whole gradient of radius times gradient of tangent equals -1, and then actually make the gradient of the tangent the subject by dividing both sides by the gradient of the radius. Okay, but we have that now. Now that we know the gradient of the tangent, okay, got the gradient, you see that to find the equation of this tangent, you already have a point. So we can just use that point and the gradient to find it. So the point is P, 3 and 9, which we have here. And we can just go ahead and use y equals to, let's just use y equals mx plus c, since I always use the other one. So that's your x and that's your y value. That's P, the point on the tangent. And we're going to say 9 is equal to, and we have the gradient being -1 over 3, and then the x value is 3 plus c. So we're just solving for c here because we already have the gradient as -1 over 3. So when you multiply these two together, your numerator and denominator cancel and you're left with -1. So that's 9 and you have -1 here. But if you take it over, it becomes a +1, which gives you a 10 is equal to c. Okay, so that means your equation is y is equal to, your gradient was -1 over 3x, and your y-intercept is +10. So that is the equation of that line, okay, the tangent. Moving on to the next question. Okay, 4.3 says, show that the equation of the circle with center M is equal to this. So we just have to find the equation of the circle. So to find the equation of a circle, all you need is the center and 1 point on the circumference of the circle. So we can just use these 2 points, okay? M and P, and let me just write those down. Okay, and then the equation of a circle, right? The standard form is x minus a, which is the center, squared plus y minus b, which is the other coordinate, the y coordinate of the center, squared, is equal to r squared. Okay, so now that we have this, we can go ahead and substitute the center. Because m is the center, that is going to be the a and the b value. Okay, so we can put that there. So that's a and b. So that's going to be x minus 1 all squared plus y minus the b value is 3. So all squared is equal to r squared. So as you can see, this equation is almost complete. It just needs the r squared value. So to find that, you can substitute the other point in place of x and y, because that's an x and y coordinate. So we're going to say 3 minus 1 all squared plus 9 minus 3 all squared is equal to r squared. And so 3 minus 1 is 2, 2 squared is 4, and 9 minus 3 is 6. 6 squared is 36, and together they give you 40. So that's equal to 40. Okay, now that we have r squared, you can substitute it into the part that just needed the r squared. So that is going to be complete. So we have x minus 1 squared plus y minus 3 all squared is equal to 40. Okay, now at this point, do you see that they distributed? So we're also going to have to do that. So let's go ahead and work with this. We square the first term, which is x squared. Square the last term, which will give you +1. And let me just make space. Okay, so that's x squared. Last term squared is +1. Then to get the middle term, you're going to say double of the first term multiplied by the second term, which if you multiply, it's going to give you -2x. Okay, same thing over here. First term squared is +y squared. Last term squared is +9. And then double of the first term times the second term, which is -6y, okay, is equal to 40. So this is what we have. And you see that the way they wrote it, they wrote x squared and then y squared first. So, and then the x and then the y. So we're just going to rewrite it like that. So therefore, it means that x squared plus y squared minus 2x minus 6y. Then we have a positive 1 plus 9, which gives you 10. So that's 10. And we can take the 40 over. Minus 40 is equal to 0. Okay, because they also just left the right-hand side equal to 0. So this is x squared plus y squared minus 2x minus 6y. 10 minus 40 is negative 30 is equal to 0. And that is the equation of our circle. Okay, so that is it for 4.3. And then we move on to the next question. Okay, 4.4, we are told to show that D is equal to 7. Okay, so the D they're referring to is this by R that we have over here. So we have to show them that this is equal to 7. Okay, let's just look at what we have. First of all, do you see we have a Y value, and that's great. That can really help us a lot. Now, to find this, let's also just complete the other things that we have. We know the value of L. We know that L, the coordinate is -1 and -3. Okay, so we know that already. So we can just fill that in. Those are -1 and -3. And now to find R. Okay, so I see a big thing with Euclid here. Do you see that because this is a diameter, the angle supported by the diameter at the circumference is always equal to 90 degrees. Okay, so because of that, we can actually use that. Now, we don't actually have to tell them that because that would really just be a reason. The only thing we can tell them is that you see this line, PR, it is indeed perpendicular to LR. So we can start off with that. So PR is indeed perpendicular to LR, and then we have that. Now, because the lines are perpendicular, this is very helpful. So we have this point, it's complete. We also have this point, it's also complete. This one is only missing one value. That is good. It's only missing an x value. So it's a situation where we can create an equation, kind of like how we did here, right? Where we created this equation in terms of x. It's a very similar situation. But what we're going to use here is the fact that these lines are perpendicular. So what do you remember about perpendicular lines? Which is what we spoke about, really. So they really just focus in on the same ideas and the same rules, really. So we know that if these two lines are perpendicular, then it means that the gradient of PR multiplied by the gradient of LR would give you -1. This is an equation. So we're going to go ahead and formulate expression to find the gradient of PR, the gradient of LR, but they would be, of course, because you see PR, it's going to be in terms of D. But the gradient of LR is also going to be in terms of D, but that is perfectly fine because they're both just going to be in terms of D. And then it's equal to -1, and then that gives you an equation in terms of D that can help you to solve for D. So that's really what we're going to do here. Okay, so let's go ahead and do that. Gradient of PR times gradient of LR equals -1. Okay, so let's go ahead and find that. So we're going to say gradient of PR, that's y2 minus y1. Let's just focus on a specific format. So here with this one, I kind of want D to just always be in front. So I'm going to say 1 minus 9. So 1 minus 9 over x2 minus x1, which is going to be D minus 3. Okay, so I'm going up like that. Multiply by the gradient of LR. So with gradient of LR, again, I want D to be, in front. So I'm going to start with this being the y2. So that's 1 minus -3, which becomes a positive 3, over, and then D minus -1, which is D plus 1, is equal to -1. Okay, so as weird as this equation looks, we can actually use it to solve for D. So let's just simplify what we need to simplify. 1 minus 9 is -8 over D minus 3. And then multiply by, that's going to be 4 over D plus 1 is equal to -1. So we are multiplying fractions. When multiplying fractions, you can simply just multiply the numerators, which would give you, that is like -16 times 2, -32. And then over, now multiply the denominators. Now the denominators are binomials. So how you can multiply them is really like this. So say d minus 3 multiplied by d plus 1 is equal to -1. Okay, this is looking good. At this point, because we have an equal to sign, we can actually cross multiply. But how I'm going to think about cross multiplying is, let's actually just tamper with this -1. Okay, I see it's -1, but we're going to put it over 1 so that it's a fraction. And then I'm going to take that negative and actually give it to the denominator. Here's why. When we multiply across, we're saying -32 times -1, and then that gives us positive 32 is equal to, and then we're saying this d minus 3 and that, right, times the 1, and it'll stay exactly the same. D minus 3 times d plus 1. There we go. Okay, now we can just work on solving for d, which we know we'll have two solutions. So there's still a 32 here, meaning you need to distribute before factorizing. So that's going to be d squared multiplying by foiling, and then plus d, and then minus 3d, then lastly -3. Okay, we can bring that 32 over. So minus 32 equals 0. Now we have d squared, and that becomes -2d. And what is -3 minus 32? That's -35. Is equal to 0. And we can factorize now. Is equal to 0. D times d gives you d squared. And then factors of 35, that can give you 2. I'm already thinking of 7 and 5. 7 and 5. Okay, 7 times 5 is 35. And then if you say -7 plus 5, that gives you -2. So we're going to go ahead and put -7 here and positive 5. Okay, so therefore this means that d is equal to 7 or d is equal to -5. And we can look in the diagram to just see where d is. And I remember them saying something about d. Yeah, they told us that d is greater than 0. So keep that in mind. D is greater than 0. So we cannot take the -1. And so we're going to leave that one and tell them that this is our answer. So you can tell them, but d is greater than 0, and say, therefore, d is equal to 7. Okay, so that is our answer for D. That is 4.4. And moving on to the next question. Then we have 4.5, which says calculate the size of angle L. Okay, there is angle L. Angle L is over here. So I'm also just going to fill that in. That is 7 now. So we're calculating the size of an angle in analytical geometry. I'm not even going to try to look at it through an Euclidean geometry angle. I don't really have to do that. That's also 90 degrees, okay? And that's 90. Just make sure to include everything that needs to be there. So rather than looking at it like that, I'm going to already look at it as if we were just dealing with this in analytical geometry only. What you can do to find out how an angle is created, because you see, angle L is this angle over here. It's not a simple angle of inclination. So you have to find out how it was created. So you're going to first of all draw at the point of L, right? You will draw an imaginary x-axis. So a line going through like that, that passes L. Okay, so it's parallel to the original x-axis because it's just another x-axis. And now we can actually find out how this angle was created. So look at it like this. You see this angle L? It's this angle over here. How do we create that? Well, if you found the angle of inclination of the line of this line, so you see going from the x-axis to that line, and that is the diameter, okay? So we can say the line PL, okay? If you found the angle of inclination of that line, and then you found the angle of inclination again from the x-axis to that line, let's just change the color, x-axis to that line. Do you see, okay, that line LR? Do you see that if you subtract these, you're going to be left with this angle? So we're really saying this entire angle, right, minus this angle gives you this angle of angle L that we're looking for. And that is how we would find angle L. So angle L will be found by finding the angle of inclination of the bigger line or bigger angle, right, that line there, PL, minus the angle of inclination of that smaller one, LR, and we'll be able to find it like that. Okay, that looks good. And I remember I was working with LR previously, so this should be fine. Let's go ahead and do that. Okay, so that is what we're going to deal with. Let's see, how can we actually find those angle of inclination? To find the angle of inclination, you need the gradient of the line. So to find that angle of inclination, we use this formula. Tan of theta is equal to the gradient of that line. Okay, so all we have to do is now find these gradients. So the gradient of PL and the gradient of LR. Let's start with the gradient of PL. So with the gradient of PL, let's see, where is that? Well, do you remember that that is the diameter? If this is the diameter and that's the gradient, if you knew the gradient of PM, which we do know, then you know the gradient of PL because they lie on the same line. They're collinear, so they have the same gradient. So what is the gradient of PM? We knew that. That was the gradient of the radius that we found here. Okay, the gradient of PM was 3. See, PM. So we know that. Okay, so we know that one already. So check. I'm just going to say we know that that gradient is 3. So gradient of PL equals 3, since it's the same thing as the gradient of PL. The only calculation or the only thing we can show them there is really just telling them this. Okay, gradient of PL is equal to 3, which is the gradient of PM. Same thing, equals to 3. And then now the gradient of LR. Now that one is something we were trying to calculate here. See, gradient of LR. So you see at this point it was incomplete. We can just take it from here. But we know what D is now. So now we will be able to substitute that and we'll know exactly what the gradient of LR is. So gradient of LR is equal to, and we'll just rewrite what we have there and substitute D. So 4 over D plus 1, 4 over D plus 1, but we know what D is. D is 7, so 7 plus 1. 4 over 7 plus 1, that is 8. So 4 over 8 is a half. Okay, so we know these gradients and we can actually find that angle L. Okay, I should have said angle L equals. Okay, now we can say, therefore, this means that to find these angles, let's just find them separately. So we'll find the angle of inclination of PL first. That's tan of theta is equal to our gradient. PL is 3. And now we can find that angle. The angle of inclination of PL is shift tan of 3. Okay. I'm not going to find the answer now. Leave it like this so that we can just use that as it is. And then we'll do the same thing for LR. So that is tan of theta is equal to, and it's 1 over 2. So that is theta of LR is equal to shift tan or arctan 1 over 2. Okay, now we can finally use this to find these. So remember how we said this is how we find the angle L. So we'll tell them angle L is finally found by saying, again, the angle of inclination of PL, which we now have as this. We're going to take that, shift tan of 3, and you subtract that by shift tan 1 over 2. Okay, that way there's no rounding off or anything like that. So angle L is finally equal to, and we can just find the answer. And that, as you can see, gives us 45 degrees. So we know angle L. That is perfect. We know the angle L, and we're going to fill that in as well. So that is done with that question. Angle L is equal to 45 degrees. Done. Okay, moving on to the next question. Okay, so we're on 4.6, which says TR is a tangent to the circle at R, and we need to prove that PT is perpendicular to RT. Okay, so let's see what they're speaking about. Let's try to actually bring this diagram down because it's just going to be very helpful when it's down. Okay, so there's the diagram, and they already told us something about TR. Okay, so we're joining these points. So TR, they said, is a tangent. So we can use all tangent properties on that. TR is a tangent to R, and we need to prove that PT is perpendicular to RT. Okay, so that over there. Let's look at this. How do we prove to them that these are perpendicular? Okay, we can look at it in different ways. You can do it with shapes, like spotting a shape that would have a 90-degree angle here as well. So to do that, would actually have to connect something. So MR, we're going to just construct a radius here. If you construct a radius, it's something we should know about a radius. Okay, this is actually turning out to be not as bad. Seems to be, how many marks is this? It's 3 marks. Okay, so let's look at the steps that we can take here. If we can show them that this shape, right? We have this shape, and we can show them that it is either a square or a rectangle. That would prove that that is 90 degrees. Okay, so we can go that angle. How would we prove that something is a rectangle or a square? For you to do that, you need to first prove that it is a parallelogram. And to prove a shape is a parallelogram is really simple. You can either prove that all the sides or all 2 pairs of opposite sides are parallel, or you can prove that 2 pairs of opposite sides are equal. Okay, I see that we can actually take a different approach to making the lines all parallel. Here's the thing that we can actually see here. Do you see how we constructed MR, right? MR is a radius. However, there's some Euclid in here. You see that this is angle L, right? And angle L is supported by the line PR. However, at the center, we also have another angle, MPR, being supported by that same line, PR. So the angle at the center is always going to be twice the angle at the circumference, supported by the same chord or arc. So here, if this is 45 degrees, this is double that angle, so this would be 90 degrees. And that is going to actually be very helpful. If this is 90 degrees over here, we can actually just tell them. So tell them that angle PMR is going to be equal to 90 degrees. If you like, you can tell them because of angle at center being equal to twice the angle at the circumference. So if that is the case, then you see that this is a quadrilateral. So all the angles need to add up to 360 degrees. So because of that, if you add all of these angles up together in this quad, so in quad PMRT, right, all the angles must add up to 90 degrees. We've got 90 degrees over there, adding with angle T. Okay, we can just call that angle T because there's no confusion there. Plus this angle over here, which is 90 degrees. Okay, so at this point, I noticed I didn't actually state that that was 90 degrees. We should. So that would have been before all of this. We should have already written that down. We should have told them that MR is perpendicular to TR. So MR is perpendicular to TR. Okay, then we're telling them that this is 90 degrees. And then if you add all the angles inside the triangle, so this angle 90, the T, this angle 90, and this extra angle 90 degrees, then they should add up to 360 degrees. We don't really need a reason. So it means that angle T plus 270 degrees is equal to 360 degrees. Therefore, angle T is equal to 360 minus 270, which is 90 degrees. And so that would prove that it is exactly 90 degrees. I think that's fine because that's 3 statements we're really making. We show them that these two are perpendicular. We show them that that angle is 90 degrees using what we already had there. And we have shown them now that that is. So that's 3 points, 3 statements that we've made. So therefore, it means that these 2 lines are perpendicular because angle T is 90 degrees. So we can tell them that it means PT is indeed perpendicular to RT. Okay, I'll just go with that because it seems fine. It's like 3 separate facts or statements, so things that we found. Okay, so that is it for analytical geometry, grade 12s. I'm sorry that I'm uploading these really slowly. I think in question 1 for paper 1, I did mention that I was going to be really busy this year. So I will try to get the remaining parts out, just edit them and upload them. And I will see you guys in trigonometry. Bye.